Hello people. In previous class we discussed about time limit exceeded error. In this class we'll discuss about approaching a problem, approaching any problem. So far we discussed time complexity, we discussed how to find iterations, and we have seen big O notations, then we have seen time limit exceeded. Now we will see how do you approach any problem. First read the question carefully and constraints carefully. This we have seen what is the importance of constraints. We'll also take one example to see what is the importance of constraint in this lecture also. A detailed analysis we'll do. Then once you read your question and constraints properly, then formulate some idea or logic in your mind. Okay. Then verify the correctness of your logic, whether it works for the given question. Then mentally develop a pseudocode. When I say mentally develop a pseudocode, you can think whether your approach is having a nested for loop, which is order of n square, or it's a single for loop, but the number of iterations is by half, so it is running by it might run by order of log n, right? Then determine the time complexity, determine the order. Now, as we said earlier, access it after you have access the time complexity, see whether it is feasible and check whether no TLE. That means I have discussed, right, whether your iterations are falling way less than 10 power 7, it's good. Then evaluate your logic, and if constraints are not met, re-evaluate. Once you re-evaluate, you can code again. So coding is my last option. First get some idea whether your approach is working or not, or whether your constraints are met or not, right? Then if you do if you follow this manner, right, if you follow all these steps, you never end up in TLE, right? But your code logic should be good, right? Now we will see the importance of constraints. Okay. So let's say your question is having this constraint that number of iterations can be between 1 and 10 power 5, right? So we'll take we'll consider we'll take few complexities. Let's say for the given question you need a nested for loop 3 times, and your order of time complexity is becoming order of n cube. Other approach, you have order of n square log n. Third approach is order of n square, and fourth approach is order of log n. You have all these approaches to solve one problem only. Which approach to decide? If your constraint is 10 power 5, so just apply 10 power 5 whole cube here because it is order of n cube. You'll end up seeing 10 power 15, which is we discussed, right? Anything less than 10 power 7 is good. Anything between 10 power 7 is 10 power 8 is okay. We have to revisit. Anything above 10 power 8 you shouldn't prefer. So what did I get? So all this we discussed in last, you can watch the time limit exceeded video. So if your iterations is 10 power 15, that means whether it works. No, it don't work. It won't work. You will sure get time limit exceeded. Now, if your approach is like order of n square log n, so if you substitute here, it is 10 power 10 log 10 power 5. 10 power 10 into something which is always greater than 10 power 8. So this also won't work. You will end up having time limit exceeded. Now again 10 power 5 whole square, which is n square. Here also your approach won't work because we are looking something for less than 10 power 8, right? Now you take 10 power 5 log 10 power 5 log 10 power 5, right? It's somewhere between, so 2 power 10 is 1024 and 2 power 20 is, so this value is somewhere near to 20, right? If it is near to 20 into 10 power 5, that is still this value cannot exceed cannot exceed 10 power 6 only. So if it is less than 10 power 8, strictly less than 10 power 7, so this solution will work. So you have to go with any approach that is having order of n log n or less than this. We have discussed the comparison order also. This is the importance of constraints. Now in general you will see one more constraint, that is around 10 power 6. For 10 power 6, let's evaluate. For 10 power 6, let's evaluate the complexities. We'll check whether it works or not, right? So I have order of n square. We'll go little lower. I have order of n log n, and I have order of n. So if you take order of n square, and the limit is 10 power 6, I'll get 10 power 12. Here I'll get 10 power 6 into log 10 power 6, which is around 10 power 6 to 10 power 7, or little above 10 power 7. Okay, little above 10 power 7. Now this is around 10 power 6 strictly. So in my first case, no, it won't work, because we discussed it shouldn't be greater than 10 power 7. Here it is around 10 power 7. This may work. So I'll put another color. So this may work. But if it is 10 power 6, for sure, yes, it works. So here if you want to go with this approach, it may or may not work sometimes. So you have a solution for order of n, please go for it first. If you don't have it, you can try with this one, right? It may work, right? And why we are talking about constraints this much, I'll give you one advice. See, if your constraint is talking something like my n will be around 1 to 100 only. I mean, for bigger computations, they are not expecting for bigger numbers only. So my iterations, they are expecting only below 100. In this case, if you clearly see, even your order of n cube will pass. See, order of n cube means 10 square whole cube, which is 10 power 6. So if you are having 3 for loops, right, will also work. Generally, people will be in a notion that if it is 3 for loops, order of n cube, you will sure get time limit exceeded. Now this is not dependent on order. It is actually dependent on the given constraint of the question. Okay, so if you are seeing in question, the constraint is around 1 to 100, you can go for order of n cube as well. And if my constraint is saying, generally if my constraint is saying 1 to 20 only, right, I can go for even 2 power n. This is a very, if you check the comparison order, this is a very slow algorithm, right? Very slow order, right? Still you can go for it. It has nothing to do with, processing speed. These two will be less than 1 gigahertz of processing speed only. Yeah, that's it. Today we learned not only the order, the constants, looking at the constants is very, very important. Thank you all. I'll meet you in the next lecture.